Now we're going to look at 2013 question 1 part B. It's a linear acceleration question and it's a nice multi-stage question. So we have a look at this. The lift accelerates from rest with constant acceleration, reaches speed v, continues at a constant speed, and then decelerates. So let's have a look and see what this one is going to look like. In part 1, we're asked to draw our speed time graph, which is a great place to start anyway. So there we are, speed time. Now always check, is it starting from rest? And in this case it is. Constant acceleration f, steady speed, constant deceleration f, same acceleration, deceleration. So there's our total speed. Reminder that it's at 0. Now, we're told here the total time is t. We'll split it up into little sections. And we're also told, if we go back and have a look at the question, that the time at the constant speed is t1. Which is just annoying because I really want to call this one t1. But now I'm going to have to call this t2 for the moment. And you may notice that this guy is also t2. Because acceleration is f, deceleration is f. Okay, so that's our speed time graph on. These guys should be nice and solid, should be comfortable drawing these. Part 2. Show the velocity is half f t minus t1. Now if we look at that equation, what I don't see in there is t2. So let's get rid of that. So if we just take a little bit of space over here, we know the total time t is t2 plus t1 plus another t2. Okay, so that's 2t2, t2, watch the now carefully, plus t1. I'd love to know what t2 is. So let's just move that around a bit. 2t2 is t minus t1. So t2 is a half t minus t1. That's great. That's a little bit easier to work with. And again, if you go back and look at what we're being asked to show in part 2, this looks like a big part of it. So over here, we're just going to take the first section to work with. Using our nice simple v equals u plus at. We then know that the velocity is actually v. That's 0. F is the acceleration, and t2 is the time. All right, tidying that up again. V equals f, and we'll swap out the t2. It's now a half t minus t1. Tidying it all up, we get f equals a half, v equals a half f t minus t1. Exactly what we're asked to show. QED. So, now on to the next part. We'll squeeze it in here and we're going to get 2 columns as we go down along it. Show T1 is that horrible thing there. We've got square roots, we've got squares, and we've got fractions. Everything here, all the fun bits, and not a single number in sight. So where on earth do we go with this? Well, let's stop and have a look at it. The new variable we have in here is distance. Okay, that wasn't in any of the stuff we had before. So how do we bring distance into it? Well, we know that distance is equal to the area under the graph. Okay, in a lot of these questions, this is the way to go rather than s is equal to ut plus a half at squared and so on. So let's see if we get this one to figure out. So putting our own ones into it, d is the total distance, we're told that in the question. Okay, I'm going to work with the original things we have here and we'll sub in as we go along. Well, it's a half v t2, okay, t2 and v there, plus v t1 plus a half v t2. Okay, tidy that up, so it equals v t2 plus v t1. That should of course be t1. Watch the little things. Now, again, let's see where we go and see what we don't have. We don't have t2, so let's get rid of that guy. All right, and that equals v, we have our t2 up here, is a half t minus t1 plus v t1. Okay, let's go back and do a little check. We also don't have a v in here. So it's going to do a little bit of housekeeping here. I'm going to put the v on the outside. V equals a half t minus half t1 plus t1. Okay, just take a little moment to make sure we haven't jumped or lost anything in that process. And of course I can see I can tidy this up even further, so we'll do it now. V factor of half t plus half t1. Okay, now let's see what we can do. So we want to get rid of v. Unfortunately, we found v, and if you ever do get stuck along the way, often the earlier parts of the question will actually be asking you to do similar things. So we'll sub in v. Sub in v. So this equals, it's going to get a little bit uglier before it gets pretty again, is half f t minus t1 by half t plus a half t1. Now you may begin to realize we have a t minus t1, a t plus t1. Those things tend to work out pretty nicely, so we'll get rid of the halves. And we'll just get one more line down here. So that's going to be 1 over 4 f factor t minus t1 t plus t1. Now it's looking a bit better. So we're going to come up here. So what was on the other side? We had d. Okay, so let's say we have d equals f over 4, we'll just combine those two. A factor of t squared minus t1 squared. Little check in, and this is looking rather good. We have all the bits and pieces we need, so it's just a question of tidying this all up. So we'll send all these guys over together. Okay, 4d over f equals t squared minus t1 squared. We want t1 on this side, so let's put rearrange. t1 squared equals 4d over f minus t squared. And of course, we have actually done a little bit of boo-boo. We slipped these ones around, so we'll just stop and check. And what I'm doing, as I'm going through it, I'm checking the solution. It's really nice when they ask you to show it, because you don't have to worry about making these small slips. So we'll just write that out again. t1 squared, okay, because that's come over here and that's gone over there, is t squared minus 4d over f. And now we can see it's nice and steady. We're on the home run. t1 is the square root of t squared minus 4d over f. QED. And we're sorted.